Hi everyone, and welcome to Eric's Electronics Workbench. So on the bench I have this incredibly heavy and large power inverter. This unit must weigh at least 60 pounds, maybe even more. But despite its physical size, the output's rated to just 500 VA, or about 500 watts. So as far as power inverters go, it's not all that powerful. Inverters can certainly exceed many kilowatts of output capability. Now compare this inverter to, say, a modern inverter like this model right here. It's a drastic difference in size. So this inverter was the subject of a repair video I did quite a while back. Now this inverter is rated 300 watts, and this is a 500 watt inverter, so they're similar in output capability. But why the big difference in size? Well, it has to do with the transformer that's inside the inverter. So in modern inverters, the transformer is switched at a very, very high frequency, many tens of kilohertz or maybe even 100 kilohertz, where this inverter, just going by its physical size, it must be switched at just 60 hertz. So the higher the switching frequency on the transformer, the smaller the transformer can be manufactured. There's just less iron in the core. So it allows these modern inverters to be very, very compact, and they're very efficient. I'm sure this inverter is not nearly as efficient when it runs. So let's take a closer look at the front panel here, and we'll also look at the back panel. Now, one of the things I noticed is that there's a calibration tag here, and it says 16th of July of 91. So as of making this video, it's 33 years ago. So does this thing still work? Well, look, we're going to find out. So let me get you zoomed in a little bit closer here, just so you can see some of the details on the front panel. So there's a red indicator light right here. I'm sure that'll come on when the output's active. So it says 115 volts AC output, again 500 VA, or about 500 watts. So the output receptacle right here. It's interesting, they have a side slot, so this is a 20 amp style receptacle. I'm not sure why they would use that, because you're definitely not going to be pulling 20 amps from this inverter. Maybe they just wanted to make it universal so any kind of a plug would fit. But again, usually a device with a 20 amp style plug like that, it's going to need a lot of current. You're just not going to be getting that with a 500 watt inverter. But nonetheless, up here on the data tag it says inverter power static. So static just means that there's no moving parts. It's not a rotary inverter like an old style, like a dyno motor or something like that. And right here it says 24 volts DC input, 115 volts AC, 60 hertz out. And then United States Marine Corps, so it's obviously made for the U.S. military under contract. And there's a contract number right here. And in the middle of the contract number it says 83, so it's a 1983 contract. So the unit's been around for a number of years now. Now, it's made by a company called Firmatech Corporation, Portland, Oregon. I'm not familiar with that company. I couldn't really find anything online. I did try and look up, if there's any tech info on this inverter, but I really couldn't find anything at all. I do see a company named Firmatech, but they don't seem to be related to inverters or anything like that, so I don't know if it's even the same company. National stock number there for identification. So over here, there's a fuse, and this fuse says 5 amps, so this must be the fuse for the output. And if we turn this here, let's take a look at the fuse. And yep, the fuse looks okay. So the fuse holder actually has a voltage rating there. It says 90 to 250 volts. The reason that there's a voltage rating on that, notice this is kind of a clear cover. So there's actually a neon indicator light inside this cover. So if this fuse blows, that indicator will glow. So it's just an indication that the fuse has gone away. And O-ring right there just to keep moisture and dirt and everything out. So look at this back like so. So toggle switch right here, main power on and off. I'm sure that there's a relay inside to do the main switching. This toggle switch just, has a feel of just a typical toggle switch. I'm sure it's not handling the main current. And speaking of current, there's no mention on the inverter of what the input current, draw is going to be on this. So it's 24 volt input, but there is no mention of that input current rating. So we'll have to find that out. We'll put a load on the inverter if it works, and we'll see exactly what happens. So input terminals right here, it just says warning, observe polarity, and these just have wing nuts right here just to connect the wires, so easy enough. Put some cables on there and be able to power it right up. So let's take a quick look at the back panel here. So as I mentioned, this thing is pretty heavy, and actually there's a tag here on the side too. We'll take a look at that. So not a lot going on the back panel. It has a note here, caution, parts under this cover are at battery potential, 24 volts. Do not short them against the case. And you can't really see it on the camera, of course, but if you look down into the heatsink, there's some large studs that are sticking out, so there must be some power devices that are on this heatsink, and those studs, they're isolated, but they're electrically hot. So if those studs have a short from the stud to the case, you're going to have big problems. And tucked away right in the corner here, I know it's dark on the camera, but there's a circuit breaker right here. It's a little lever right there that moves up. So I'm sure that's probably, since there's a fuse on the front for 5 amps for the outlet, this is probably the main breaker for the DC input. Turn this back again on this side right here. And did I mention this thing's heavy? Really, really heavy. All right, so if we take a look right here, you can see some notes about operation, and one thing that's interesting down here, it just says that after the inverter is operating, 500 watts of 115 volts AC power is available. Always use at least 150 watts of output power for best operation. So for some reason they want kind of a minimum load on the inverter. So I'm sure if you don't have a load, maybe the output is somewhat distorted, or it's just not running at its best efficiency, something like that going on. So that's kind of interesting that they do have that note on there. So let me take the top cover off. Let's take a look around inside the inverter and see how things look inside, kind of what the design is, make sure that it looks okay. Maybe for all I know, it could be a chunk of charcoal inside, so let's find out. And if it looks okay to power it up, then we'll try that. All right, 2 more screws, and we'll get the top cover off here and see exactly how things look inside. That one, and one more right here. Should come off. It's kind of edged on there. There it goes. Oh wow, that looks pretty good inside. There's a lot going on in there. So what do we see here? Let's get this turned to the side. So you can see some really heavy gauge wire coming in here on this main contactor. So that's what I was thinking, that this toggle switch on the front right here, yeah, it's just turning on this relay or this contactor. So there's a tag right here. Let me get you zoomed in a little closer. Let's take a look at that. So this says contactor, there's a part number, coil voltage 24 volts, 53 ohms, 12 watt. Contacts are rated 100 amps. So we know that the current draw is going to be 100 amps or less. Now there's an inductor right here, and it says 200 microhenry and looks like 50 amps. DC resistance 0.01 ohm. So this is a 50 amp. They've definitely overrated this, and 50 amps is probably about going to be the limit of what this is going to require. And actually it looks like over here, get you moved up over to this side. So here's the circuit breaker that's on the back panel that reached through when the cover is on. You couldn't see the side right here. And this amp rating right here, it says 60 amp on the breaker. So that makes sense. If this is rated 50 amp and then just a little bit over that, then it trips the breaker. So that gives us an idea that when this is under full load, the current draw is going to be pretty much topping out at about 50 amps or so. So yeah, the unit looks really good inside. It looks clean. I don't see anything majorly wrong, at first glance. So without a schematic, it's a little bit difficult. Without further, studying a lot closer, just to know exactly what all the components do. Obviously, a control circuit board, another control board up on top. Yeah, I don't see any capacitors that are leaking or bulged. Some large electrolytics down on the side over here. Looks like there's a temperature sensor. This wire that runs along the top right here. There's 2 wires right here in this shielded cable, and it goes to a sensor that's under this screw right here, so it's probably a temperature sensor on that heatsink. And it looks like this heavy gauge wire comes in, goes through the contactor right here, comes over here to the breaker, out of the circuit breaker, and it goes down to looks like the power devices on the back. Kind of gets lost down in there, but it looks like, what do we see in this corner right here? It looks like, I would actually think that might be an SCR, just based on what that device looks like and the style, the leads that are on that device. It could be an SCR. Well, yep, actually it is. There's a marking right here. It says SCR number 2. So answers that question. So it looks like they're using an SCR, possibly 2 of them. I think, yeah, there's a second one I can see down there. It's buried away, but it looks like there is a second one. So 2 SCRs are doing the main switching in here. So let me get this positioned here and take a look at the other side. So it looks like there's some more information right here on this transformer. Let me get you zoomed in on that. Let's take a closer look. So transformer power, some part numbers looks like, and then it says primary wires, SCR1 and SCR2. Yeah, so there are two SCRs. There's a diode D1, D2, center tap, 24 volts DC. So yeah, they're bringing the voltage into the center tap and then switching both sides of the transformer. And then secondary terminals, 1 is common, 2 is 115 volts out, and 3 600 volts. Interesting, 600 volts, that's really high voltage. I can't imagine that would be used in this application, so maybe there was some other application for this transformer, but yeah, no, it's looking really good inside. So I'm going to say it's probably okay to try and power it up and see if it actually works, or does it need some kind of repair or something else going on with it? We'll have to find that out. But large terminal board here with the main, looks like wires that are probably going to the SCRs perhaps, and really can't see those devices. Yeah, they're down in here. There's really no way to get the camera on those. I can see them through these wires right here, but definitely two large SCRs. So if you can see that this transformer right here, get you to turn just a little bit here and zoom in. So if you can see the coils right here, see there's a space right here. So above my finger is the secondary winding. You can see how tall that is, and then the primary winding is down here, so that's a step-up transformer. So you have a few turns on the primary and many turns on the secondary, because you're taking that 24 volts and switching it, and you want to step that voltage up to the 115 volts. But look at the size of the core on that transformer. It's absolutely massive, so a lot of weight in that transformer. It's definitely the bulk of why this thing is so heavy. So anyway, let's get this thing hooked up to power supply, and given that this thing is going to want to draw quite a bit of current, my normal lab power supply isn't really going to be doing the job for this test, so I think we need to go to something a little bit larger, and I think I have just the power supply. So let me get that out and I'll be back. Alright, well I think this power supply will be perfect for testing that inverter. In fact, it's actually making that inverter look a little bit small by comparison. So the power supply is a model PP8474G. The output's adjustable from 18 to 30 volts. I have it set to 25 volts. The adjustment's right here. And then the output current is good to 50 amps, although some documentation refers to it as a 60 amp power supply. Now the output cable is right here. There's a Canon plug or a circular connector right here, but this large cable comes over and just goes to this junction box, and then there's two terminals on that junction box. So let me get some wire between that junction box and the input terminals on the inverter, and this other connector right here on the power supply is 120 volt input power. So let me grab this. So what I have is this wire right here. It's just ultra flexible 12 gauge. So the 12 gauge really isn't large enough to run this under 100% load, but it'll be a starting point to just do some testing here. So let's start over here and just get this connected to this junction box here, like so. Alright, so that's in place there. Do this around both sides of the camera here. Alright, so positive on this side right here. So. Alright, those are nice and snug there, so that should work. Okay, so inverter is turned off, that's fine, and I'll go ahead and switch the power supply on. All right, there we go. So we have 25 volts and no current draw, so no problems there, that looks fine. All right, so let's see what happens. Does the smoke fly, or is this inverter going to function correctly? Here we go, let's see. Oh, seems to be working. So this actually, you can see that's a neon indicator lamp, so there must be 115 volts to make that indicator lamp glow. So put a voltmeter on here and we'll check the output, but no excessive current draw over there. That looks pretty good. So it looks like this didn't move very far. So there's 20 amps, and then the next large tick mark is 10 amps, and then it's about halfway, so I'm going to say it's about 5 amps. I'll check that here in just a moment. But 5 amps wouldn't be too excessive. That seems probably about right. The meter here, AC volts. Let's see that. So if you're following along and you're working on a power inverter, or if you just happen to have an inverter like this, absolutely you are doing so at your own risk. Take care and be safe. Definitely high voltage in these inverters, and you don't want to come in contact with the wrong points. So again, if you're following along, you are doing so at your own risk. Let's check the voltage here and see what we have. So it looks like 111, looks like right there. 111.85. So that's not too bad. So rated output says 115. There might be an adjustment to dial that in a little bit closer, but I wouldn't be too worried about that. I really don't know what that adjustment would be. I see a couple trimmer adjustments right up there on that top circuit board, but who knows what those do. They're not labeled. So really, at this point, it's not something that I would know where the adjustment is in here. If the voltage is adjustable at all, probably is, but it's close enough, not something to worry about at this point. Let me grab this clamp meter right here. Let's check the current. So I'll just put this to DC amps, and when you do DC amps on here, you have to zero it, so we'll do that. And let's just check the current here. Yep, there it is, 5 amps. In agreement with what that meter right there is saying. So again, I have no idea, if the 5 amps is correct, but it seems right. That's probably normal for this inverter. Doesn't seem too excessive. So I have absolutely no documentation on this inverter, no specs or anything to go by. So again, it seems to be doing okay. So I think the next thing to do is to put some load on the output. So let's start, let's say maybe 150 watts. So I think I have a 150 watt incandescent bulb. So I'll grab that and we'll plug that in here, and let's see if it can handle some load. By the way, do you hear the hum on that inverter? Definitely a noisy inverter that has a classic 60 hertz, 60 cycle hum. So it definitely makes a buzzing sound. I think the camera is probably picking that up. But yeah, that definitely has a hum to it. Feel it actually in the bench a little bit too. Yeah, you definitely feel it on the inverter when you touch those handles, like a buzzing feel to it. All right, let me grab that incandescent bulb. I'll be right back. Okay, here's a 150 watt incandescent lamp with just a cord on the end. So set this over to the side here. And let's see what happens. Up we go. Yeah, no problems there. Definitely powers that lamp okay. So yeah, it's pretty blindingly bright on the camera there, but you can still see everything okay. So now let's grab this clamp meter again and see current drawings here. So just shy of 11.5, 11.4. So it's not the most efficient inverter. Definitely, 11 amps and 25 volts. So when we're only powering a 150 watt lamp. So again, not the most efficient inverter around, that's for sure. Definitely has that humming sound. That didn't change too much. And it actually quiets it a little bit though. I don't know if it picks it up on camera, but the difference in sound all that well, but it does quiet down a little bit. And remember, it mentions that a 150 watt minimum load, so it's interesting, it gets kind of noisy when it doesn't have a load on it, and then adding that load almost makes it a little happier when it runs. So I'm not sure exactly why that is, but nonetheless it's what they have in the instructions. Let's increase that to, let's say, 300 watt. I have a 300 watt incandescent lamp, so let's try that. Let's put 300 watts on it and see how it does. Alright, here's a 300 watt incandescent lamp, so let's see how the inverter does with the 300 watt load. Set this back here. And before I do that, one thing I forgot to check earlier was the output frequency of the inverter. So put the meter again here. I think you can see that display. Not quite there. Let me just move it over here. Easier to see it right there. Yep. So just go up here to menu, and we want to go over here to frequency. So, all right, let's try this and see what we've got here. So again, we're still at 111 volts, but 57 hertz. So it's down just a little bit. It's just under 60 hertz. So again, I'm sure there's an adjustment for that in there that could bring that up just a little bit, but very, very close. So again, if this calibration was back in 1991, 33 years ago, it's not doing too bad 33 years later. All right, let's see how this handles 300 watts. Right, here we go. Oh geez, man, that is the one loud inverter. So pardon the blindingly bright light over there on the side, but it is working okay. It's handling the 300 watt load. So I'm gonna grab my clamp meter again here and let's take a look. So yeah, 17 amps and some change right there. So yeah, that's not the most efficient inverter, that's for sure, because 17 amps and 25 volts when it's only powering 300 watts. So a lot of loss in this inverter is heat. I'm sure that heatsink is getting quite warm back there, and just the general losses in the transformer and things. But it is working okay, so that's a good sign. Now I can't go to 500 watts because this 12 gauge cable just isn't going to be large enough. In fact, I can already feel some heat in this wiring on this cable. So it would need a much larger cable, you know, to connect things here to go to 500 watts. I can't even imagine how loud that would be at 500 watts. It really has a loud buzz to it. You can feel it in the handles and even a little bit on the workbench right there. Well, before I unplug it there, you can see that meter right there. Let me zoom in just a little bit closer. So you can see this is just shy of the 20 amp mark right there, so makes sense. It confirms what that clamp meter is reading, and voltage is sitting right at 25 volts. So I'm going to unplug this lamp over here. So yeah, wow, that is loud. Pardon the camera movement here. I'll go ahead and shut that off here. Yeah, that is one noisy inverter, no doubt about that. But yeah, the transformer's got some warmth to that core. So how about that heat sink? Yeah, it's warm. Warm but not hot. Nothing, I wouldn't say it's excessive by any means. So I would say the inverter is working okay. So again, not too bad after 33 years since its last calibration. So if you enjoyed this video, don't forget to give it a thumbs up, and if you're enjoying the videos on this channel, please remember to subscribe. There'll be many more videos coming up in the near future. So thank you for watching, and until next time, take care. Goodbye for now.